Section 2.9, hyperbolic functions. So we start out with a joke about hyperbolic swine, which is kind of cute, I thought. And then this neat video of a man riding a bicycle with square wheels. And let me just show you that. Notice that the wheels are square, and yet the bike is staying level. The bike is staying completely level, and that's because he's riding over a tract, which is a catenary. And a catenary is defined by hyperbolic functions. So the nice thing about this section, there's nothing you need to memorize. I want you to come away from this section not being afraid of hyperbolic functions, knowing that they're just e to the x's and e to the negative x's, and that they occur in nature. So they're important functions. They have their own set of derivative rules, but they're not scary. Their name is a little scary, but they're not scary. And so the definitions, really we just need to know the definition of sinh and cosh, and that's how you pronounce these two functions. This is cosh, and this is sinh. And the other hyperbolic functions are defined in terms of those, like hyperbolic tangent. And there's no pithy way to say hyperbolic tangent. You just have to say it all. Hyperbolic tangent is sinh over cosh. But you can see that cosh and sinh are just combinations of e to the x and e to the negative x. One has a minus in it, and the other has a plus. Okay, so let's look at what we can do with these functions. First of all, let's show that sinh is odd. Just like sine is odd, sinh is odd too. So the only way we're going to be able to do this is to look at the definition. Sinh of negative x is, everywhere in this formula that I see an x, I'm going to put in a negative x. So minus e to the negative x over 2. Okay, well that's e to the negative x minus e to the x over 2, which is, if I pull a minus out, that's e to the x minus e to the negative x over 2, and that is negative sinh of x. Okay, let's look at some calculus. Don't memorize these, but here are the formulas for the derivatives. They're very similar to the formulas for the derivatives of the trig functions, except with sinh and cosh, it's actually easier because there is no minus. The derivative of sinh is cosh, but the derivative of cosh starts with a c, and yet it's got a positive derivative. The only three negatives are over in this column. And you can use this table as you do your homework. I'm okay with that. Like, again, I don't necessarily want you to memorize these derivatives. You just won't use them enough to warrant memorizing them. So let's find the derivative of hyperbolic tangent of 3x. So we're just going to use the chain rule. So this is equals, because I've got the derivative sign there. Now I'm going to drop the derivative sign and take the derivative. So the derivative, I'm going to take the derivative of the outside, leave a space, which is hyperbolic secant. So secant h squared of 3x. And then I'm going to multiply in the front by the derivative of 3x, which is 3. That's exactly how I would have taken the derivative of tangent of 3x. I would have said, okay, that's secant squared 3x, take the derivative of the parent, leave the baby alone, and then multiply by the derivative of the baby. Okay, another one. This is going to require the quotient rule. So f over g prime is f prime g minus f g prime over g squared. So here we go. Derivative of the top. Derivative of 2 is 0. The derivative of cosh is sinh. So I multiply by, that's f prime, and I multiply by g, 3 minus cosh x. And then I subtract f, which is 2 plus cosh x, times the derivative of g. The derivative of 3 is 0. The derivative of cosh is sinh, so I'll get negative sinh x. And all of that gets divided by 3 minus cosh x squared. Okay, let's distribute. Upstairs, 3 sinh minus cosh sinh, cosh x sinh x. Then when I distribute the 2, I get minus 2 sinh, but then I have another minus, so it's going to be plus 2 sinh. And then when I distribute the cosh, I get positive cosh x sinh x. You can write cosh sinh or sinh cosh. And the denominator just stays there. 3 minus cosh x squared. All right, and now let's see what happens. This guy kills this guy, and we can combine like terms. We end up with 5 sinh x on the top. 5 sinh x over 3 minus cosh x quantity squared. One more and then we'll do an integral problem. Just like when you take the derivative of powers of trig functions, when I'm taking the derivative of a power of a hyperbolic function, I rewrite it. So I would rewrite this as d by dx of sinh x all cubed. So that's going to be derivative of the outside, bring the 3 down, leave the sinh x alone, new exponent is 2, and then multiply by the derivative of the inside, which is cosh x. And you can leave it like that, or, so MyOpenMath accepts answers like that, or you can rewrite it as sinh squared x cosh x. Either or is fine. Okay, application. Find the length of a cable that's defined by this equation over the interval from -50 to 50. Now, actually, when you go out and you look at a power line, you got 2 poles there, and then there's this cable hanging in between. And that cable looks like a parabolic arc. It's actually not. It's a catenary. Same thing with a jump rope. When kids are playing jump rope, you know, they've got that rope hanging in between them. Here's a kid. Here's a kid with no arms. Let me give him arms. Okay. Again, that's a catenary. So let's find the length of a cable of a catenary, and I'll remind you of the arc length formula. L is the integral from a to b of the square root of 1 plus f prime squared dx. So this is a fun problem because A, we have to take a derivative, B, we have to integrate. And we're going to need a trig identity. Now, hyperbolic functions have their own sets of identities, which are different than trig functions. For trig functions, cosine squared plus sine squared is 1. For hyperbolics, it's cosh squared minus sinh squared is 1. So we're going to need this identity here in a minute. And you'll need it on your homework, so you might want to reference that. So here we go. Our f of x is 25 cosh x over 25. So we're going to need f prime. 25, this 25 is a constant, so it just carries along. And I'm going to use the chain rule. So I get 25. The derivative, leave a space. The derivative of cosh is sinh. Leave the baby alone. And then multiply by the derivative of the baby, which is 1 over 25. So kill, kill. And our derivative is just sinh x over 25. Okay, so our arc length is going to be, L is the integral from -50 to 50, that was given in the problem, square root 1 plus sinh squared of x over 25 dx. Okay, now using my hint, 1 plus sinh squared is cosh squared. So cosh squared x over 25 dx. But if you look at the definition of cosh, you will see that cosh is always positive. And so when we square it and take the square root, we get cosh back. There's no absolute value. So this is going to simplify to the integral from -50 to 50 of just cosh x over 25 dx. Okay, now we integrate. So imagine if you were integrating cosine of x over 25 dx. Your k is 1 over 25, and when you integrate, a 1 over k comes out. So that would be 25 sine of x over 25 plus c. The same thing happens with cosh. What's going to come out when we integrate is a 25, not a 1 over 25. So this is 25 sinh of x over 25 between -50 and 50. And so this is going to be 25 sinh of 2, because 50 over 25 is 2, minus sinh of -2. However, on the first page, we showed that sinh of negative x is negative sinh x. So this is 25 sinh 2 plus sinh 2, which is 25 times 2 sinh 2. Well, 2 times 25 is 50. So we get 50 sinh 2. Now, there are two ways to evaluate that. If I go to Desmos, I don't know, I haven't tried this before, but I'm sure it'll work. What do we have? 50 sinh of 2. There we go, 181.34. The other way to do it, if you don't have technology, suppose you're stuck on a desert island, you can use the definition. This is 50, and sinh 2 is e to the, remember the definition of sinh, it's e to the x minus e to the negative x over 2. So it would be e to the 2 minus e to the negative 2 over 2, which would be 25 e to the 2 minus e to the negative 2. But if you're on a desert island, you don't have a calculator anyway, and so you're really going to be hard-pressed to go too much further than that. If My Open Math wants an exact answer, it might take this, or, you know, put it in your graphing calculator or use Desmos and get this. I'm pretty happy with that answer because it's exact. And that's it for this section. It's a pretty easy section.